Welcome to an ACT review. This review today, we're going to be covering Pythagorean theorem. We're going to be covering distance, midpoint, just some of those ideas that you're guaranteed to see on the ACT. So let's go ahead and dive in. Looking at this first problem, let's just break down and remind ourselves what Pythagorean theorem is. This is a formula you should definitely have memorized for the ACT. You might also consider memorizing some of the Pythagorean triplets like 3, 4, 5. Those are just side measurements that guarantee to work with Pythagorean theorem. Okay, if you want to look up those up, they're called Pythagorean triplets. Realize when we have Pythagorean theorem, right, this statement, we know that C is known as the hypotenuse. C is always the side that is directly across from the right angle. It is also always the longest side. So whenever we want to find the distance between two coordinates, whether you have a triangle or you have two spots on a graph, you can do that by making a right triangle. But when we do that, we're not just going to make our right triangle look something like this, right? That does not work. When you make this triangle, you want to make sure you're being careful. You need to follow the grid. That way we can actually count how many boxes there are. If I have those diagonal distances, I get parts of boxes, and I don't want that. So maybe I start at Y and I go directly over until I'm under the W. Notice I followed the grid that way. I can go straight up and down from W all the way down to here. And now we start to see this right triangle form. By doing that, we can count the sides. I see 1, 2, 3 boxes here. We can count up and down. I believe that was 9 boxes. Let me double check. 1, 2, 3, 4, 5, 6, 7, 9. That does look like 9 boxes. So from there, then, now that we have both of these, all we need to do, these are both the sides, the legs of our triangle. We need to solve for C. So 3 squared plus 9 squared equals C squared. You could type this entire side into your calculator. It ends up giving you a value of 90. We could take our square root on both sides to get C by itself. So C is the square root of 90. You might type the square root of 90 into your calculator to also find a value. You might simplify this square root as well. There's a bunch of different ways that you might find your answer on the ACT. One thing, though, is maybe you just take the square root of 90 and find it's a value of 9.486. If they do want to know what this simplifies to in terms of a radical, remember you could figure out what perfect square goes into it. For example, 9 goes in 10 times. The square root of 9 is 3. Square root of 10 we don't know. So you could simplify your square root that way as well. That value should be equivalent to this decimal. So one thing you might do is also just use the answer choices to see which decimal is the same as it. There's some ideas with Pythagorean theorem. Realize you might have another problem like this. Let's say we did not know the let's say we knew the hypotenuse. So let's say we had a triangle where one side was 4, maybe the hypotenuse was 10. And we needed to find this missing side. Maybe we call it B. So, okay, 4 squared is 16. B squared we don't know. 10 squared is 100. And now you just need to solve. So it's the exact same idea as that last problem, but now we are solving for a different component. Take your square root, and now you have your answer. Again, your square root might simplify. You might find that value. When you go through this problem, you could find the decimal, you could simplify. There's a bunch of different strategies, but we'll just keep our answer like that for now. Other things on the ACT that we might look at is distance and midpoint. These are all ideas that are tied together. Distance is just a formula. If you have two coordinates and you want the distance between them, it's just a formula. It's a very similar idea to the Pythagorean theorem. The reason for that is these formulas are derived from one another. Notice we have two coordinates, though. We can label those as our x and y, but be more specific with an x1 and y1, x2 and y2. Now it's just plugging into our formula. Replace the x2 and x1. Replace the y2 and the y1. Type this into your calculator. Find a value. When we do so, we end up getting 4.123. So the distance between those coordinates is roughly 4 units. Again, you might simplify the radical by hand as well if you found the value underneath. But I think if you have a decimal version, you can always use the answers to find which answer may be the same as that. Another formula you'll want to have memorized is midpoint. Midpoint is simply an idea that cuts a segment in half. It takes 2 equal halves. But midpoint is also just an average of your coordinates. So if I have those same coordinates, -1, 1, and 3, 2, all we're going to do to find the midpoint is take an average of the x values and an average of the y values. Well, the x values are -1 and 3, so we could add those two values together. An average is found by adding two things and then dividing by the amount of things you've added. Well, I added just 2 different values, so I would divide it by 2. You could do the same for the y values. Find an average, add the 2 y values together, divide by the amount of things you added. When you type this in your calculator, only type in one of the fractions at a time. You cannot type in this entire thing. But when you do so, 3 plus -1/2 comes out to 1. The other one comes out to 1.5. That point would be in the direct middle of those 2 other coordinates. It cut the line in half that is formed between them. If you need a visual of that, we can go ahead and look at 15 real quick to discuss that. So 15, we've got 2 coordinates. We've got the midpoint, which is 7, 3. And we have a coordinate that is 4, 1. So let's start with 4, 1. I'm going to draw this a little better so it actually fits this kind of grid. Okay, so 4, 1, go over 4 units, up 1 unit. That is one of our endpoints. But they also tell us the midpoint. The midpoint of our function or our line segment is at 7, 3, right here. So here's our coordinate 4, 1. Here's our coordinate 7, 3. A midpoint takes a line and it cuts it in half. So we just need to go ahead and find this coordinate then. Well, in order to do that, because we went halfway, we can figure out the changes that caused us to go halfway. If we know how to get halfway, you can then apply those same changes to go the rest of the distance. For example, from going from 4 to 1, what we did is we added 3 units. We went 3 units to the right. That means our graph now should also go 3 units to the right. That means that our new value, our new coordinate, should have an x value of 10. Well, from 1 to 3, the y values, that's how much we go up and down, went up by 2 units. So if that got me halfway, I can apply the same change to go the other half. I could go up by 2 again. So that would take us here. That would make us go up 2 to a value of 5. This coordinate at the end should be at 10, 5. Looking at our last type of idea then for this ACT review is congruent. Congruent is a simple idea that means that 2 things are the same measurement, the same length, the same angle, meaning that they have equal measurements. So if you're told that 2 angles are congruent, the angles are the same measurement. They have equal measurement. If you're told 2 segments are congruent, they have the same length. They have equal measurement there as well. How you can tell if something's congruent is this little symbol here. This is a congruence symbol. Again, notice it looks like an equal sign then. It looks like an equal sign, so we can apply that idea. They tell us that these 2 segments, AB, is congruent to AC. they have the same measurement. So if I have the measurement 6x plus 7, it's the same. It is equal with 3x plus 43. We could solve that real quick, getting the variables on the same side. We could start to move the other values away. So 3x equals 36. Divide the 3 over, and now you have a value for x. That makes it so that these two parts are equal. So if I want to know the distance of one of those parts, the distance of AB, well, I know that AB is 6x plus 7, but I also know that x is a value of 12 when these segments are the same. So now I could plug in, I could evaluate that and find this is a value of 79. Okay, but if that left segment is 79, that means this right segment is the same as it. It is also 79. So in order to find the total distance BC, you could take 79, add it with itself, or 79 times 2, which that gives you 158. Thank you for watching. That is our ACT review covering distance, Pythagorean theorem, sectors, midpoints, a whole lot of stuff. Come back next time for some more ACT review.